CNC router owners ask me this one thing all the time, and it's in this video I'm going to answer that question. And it has to do with the type of CNC router bit that you're looking at right here. This is called a roughing end mill. Have you ever cut a project where you're removing a lot of material? If you have, then you know how long that takes. This type of bit is designed to cut that time down by 10 times or more because of its aggressive design and how fast you can run it. It is designed to remove a lot of material on your CNC router woodworking projects very quickly. The one you're looking at right now is a 1/4-inch diameter roughing bit called the Beast from IDC Woodcraft, and it is the most popular CNC router bit out there because of what it does and how fast you can run it. But the thing with this type of bit is it's got this knurled edge on it, which means it's going to leave a rough cut. And that means you need to leave a little material left so you can come back with your upcut or downcut end mill to do a little cleanup pass for your finished cut. And herein lies the questions that people ask me. How do I offset that router bit so that I can leave that material for that cleanup pass? I'm Garrett Fromme, CEO of IDC Woodcraft, a CNC router bit company. And in this video, I'm going to teach you 3 techniques that you can offset your CNC router bits in your designs so you can leave that extra material. As we go through this, I'd love to see your comments, thoughts, and other techniques that you might have about offsetting your CNC tools. So with that, let's go into these 3 techniques, and we're going to start off with technique number 1. IDCwoodcraft.com. Technique number 1, the allowance offset. This is the fastest and easiest way to offset a router bit from a line. You see, in the world of CNC machining, we are offsetting tools all the time for a rough cut, and then we come in for a finish cut. And the companies that create the software that generates the toolpaths know you need that ability. So whenever you're setting up a toolpath, they will always include a field where you can type in that distance where you want that router bit to offset by. And once you type that distance in, when it calculates the toolpath, it will offset that router bit from that line in that toolpath calculation. Here's how the allowance offset works. We have this rectangle here that we are going to pocket down to 1/2 inch. So we're going to select the rectangle and go into the pocketing toolpath. So we have 1/2 inch set up in our cut depth. When you're using a roughing tool, you generally want to be a little bit less than that. So I would change that to 0.48. The Beast roughing end mill is now selected. In your software, you're going to see something that may say pocket allowance or may say tool offset or something to that effect. This is where we're going to tell the software to offset that tool using the allowance offset. So I'm going to type in a number 0.04. It's a little high for a roughing end mill. I like to go 0.02, and we're simply going to calculate this toolpath and preview the toolpath. Now we're going to zoom in a little bit and turn on the vector so you can see that we've got a little bit of a material left around this vector. Then when you create your second pocket toolpath, we're going to change the cut depth to 0.5, remove the roughing end mill and select the downcutting end mill. And we are not going to change the pocket allowance. Now your software should not default into that offset. That should be new or 0 every time you go into or create a new toolpath. And then we'll calculate that one. And we are going to show that vector. So we're going to zoom in a little bit so you can see the vector and preview the toolpath. And you'll see that it will remove the rest of the material. And now with the pocket allowance, we are done pocketing out the toolpath. Now you can also use the offset with a profile toolpath, but it works a little bit differently. So we are going to create a new vector real quick. So I'm going to go into the design toolpath and we will create a line right here and get out of that. And we're going to close that toolpath. So go there and it has the line created. So we're going to now go into the profile toolpath and we're going to select that line. In the profile toolpath, we set up our depth, and when you are doing a profile toolpath, if you are cutting on the line, you cannot use an offset. You can only use it when you are going on one side of the line or the other. So I'm going to select outside right. So this should cut on the right side of this line, I believe. I don't use this feature that much when I'm doing the offset or offsetting the tool. And then we're going to come down to this allowance offset. And we are going to first set it at 0 and simply calculate out the router bit. We have to set up the proper tool. We've got the beast on here, so we're just going to go with the beast and calculate that out. And let's see what this creates. So we're going to preview that tool, and then we're going to turn on the vector, and we're going to see that there is no offset there. So I'm going to go back into the profile. We're not even going to change the roughing bit because the software doesn't know it's a roughing bit. We're going to change this offset allowance to 0.04 and calculate that out. Now you notice that the line just shifted. We're going to reset all the toolpaths and preview all the toolpaths. And then we're going to take a look at this line. And now you can see in the profile toolpath, it has left a little extra material on the project. And then you would create your finished toolpath. So we'll just simply do that real quick. We've got that vector selected. We're going to go into profile. We're going to change our router bit to the 1/4 inch downcut end mill. So I have to go find that bit right there, select it, and then we make sure we're on outside right, and our offset allowance is 0. Simply calculate the toolpath, and now when I preview the toolpath, you'll see the rest of the material will remove from this cut right in there. So preview the toolpath, and now it is cut. So for technique number 1, to offset your roughing bit on your carve, while you're creating a toolpath, you will always find a field in there that you can put a number in. It'll either say offset, offset allowance, allowance offset, something to that effect, where you type in that number. And when you do and calculate out that toolpath, the software will automatically compensate for that distance so that when it punches out the G code, it will be offset the amount that you have requested. Now, that's technique number 1. Let's talk about the second technique that you can use to offset your roughing tools in your carve while you're designing your project. Technique number 2, create a copy of the original vector and offset it. When you're designing your CNC project, you are creating your finished cut lines. What you'll do is take the line of interest that you want to cut around with the roughing bit and copy it, but offset it by the amount that you want that roughing bit to be offset by. Let me show you how that works. We have the same rectangle here. And now we want to create an offset line that we're going to tell the roughing tool to follow, and then we'll use this line as the finish line for the finishing tool. So in order to offset this, we simply select the vector, and in the Vectric software, when we come down to offset and layout, we select this particular button right here where it says offset. Select that, and we want to offset it on the inside of the line. So we got that, and then we're going to define that offset. So we'll go with the 0.04 since that's the number we're using. Again, I don't recommend that much, but you can work with it. I like to go with a 0.02. We'll create a 0.04, and we won't worry about anything else that's checked here. Now, when I click the offset of the line I've selected, and I'm telling it to offset to the inside, I click that, and now you can see we have a new line right here. And then we would go and create our toolpath. Now we're in Toolpaths, and we are going to create our pocketing toolpath. We're going to select the proper router bit. So I'll select the Beast Roughing End Mill. So we have to get into that. Roughing Tools, Beast, select it. And we now have the inner pocket or the inner line selected. We will need to change our depth. So we're going to change that to 0.48. And we'll have all our other settings set up. And then we're going to calculate this tool and reset the preview and preview all toolpaths. And then we'll take a look at our vectors. And you can see now that we have cut on the inside vector. Let's just get off of that so you can see both vectors. It doesn't work so well. We have cut on this vector here, but we have not cut on that vector. Now we can go create our next pocketing toolpath. We're going to change our depth to the finished depth, select the proper tool for the job. So we're going to remove the roughing tool, and we're going to come in and get our 1/4 inch downcut end mill, select it, and we will simply come down and calculate. And then you'll see that when we cut this, it's going to remove the rest of the material. I'm going to, again, select the vectors. Oh, we have to go back in the toolpath and select the right vector. So we want that outer vector, and then calculate. And when we run the toolpath, you are going to see that the software will cut to this vector right there. So preview all toolpaths, and now it cut out to the outer vector. So for technique number 2, to offset your roughing bit on your carve, you're creating a second vector in your design. And that second vector is offset by the amount that you want the roughing bit to be offset from the finished cut line. Then when you create your toolpaths, for your first toolpath, which is the roughing tool, you will select that offset vector, and then your second toolpath, which is the finished tool, you will select the final cut vector, or the original vector that you are offsetting from. But there is a third technique, a very interesting technique that you can use to offset your roughing bit in your carve. Let's talk about that one. Now, just before we get into technique number 3, I do want to show you about these roughing end mills. So IDC Woodcraft has all different sizes of these guys, but this one is the most popular. It is the 1/4 inch roughing end mill called the Beast from IDC Woodcraft. And we are about to cut a 4 by 7 inch pocket in this piece of oak, and we're going to cut it to 3/4 of an inch deep. Now, I've started a timer, and we are running at 300 inches per minute around this profile cut. 3 passes, and about, we're at 14 seconds later, we've created that, and now the real meat of the cut starts. We are at 3/4 of an inch deep, and we're going at an 80% step over. And now we're almost at 30 seconds into this pocket, and we're halfway done. This is the type of bit that will really remove that stuff really quick. If you've done pockets before, you know this kind of stuff takes a long time. That's exactly why this bit exists. The IDC Woodcraft Beast, this one you're looking at right here, is like the fastest CNC router bit on the planet. And you can only get this at idcwoodcraft.com, but if you have an 1/8 inch tool that you want to do, you have a 3/8 or 1/2 inch, IDC Woodcraft has all that. So this, my friend, is the Beast. I'm going to link it down below, and make sure you get one, and let's get on to technique number 3. Technique number 3, and this is a sneaky one. Change the data for the roughing tool in your CNC router bit database. If your roughing tool cuts at a 1/4 inch diameter and you set in your database that it's actually a 5/16 diameter tool, then the software is automatically going to compensate for a 5/16 diameter tool instead of a 1/4 inch diameter tool when it generates the tool path. And it will automatically leave a little bit of material left on that finished cut line. Then when you create your second tool path, the router bit that you're going to do the finish cut with is already set properly. Then you will have everything set up. I'll show you how to do this little sneaky thing. For technique number 3, where we're actually telling the software that the router bit is bigger than it actually is, there's 2 ways we can do this. The first is we can go into the core database of the router bit. All CNC software has data for each bit that's populated in the database. So we're going to come in and select the Beast. And you can see right now the diameter of the Beast is set at 0.25, which is the actual cutting diameter of the bit. But we can change that to 0.3175, or let's just change it, be more realistic. We're at 0.25, we want a 0.02 offset, so we go 0.29. And we can click Apply and OK. And what will happen is from now on, everything that you design and select that router bit, the software is going to think that that router bit is a 0.29, and it's going to carve based on that. And by virtue of that, it will leave a 0.02 left on the material. I'm not going to change my database here, so we're going to discard those changes. The other way you can do this is by going into the toolpath. After you select the project, we're going to go into the pocketing toolpath, and we have the Beast here, and we're going to select the Beast and come to this Edit button. When we select that, what we're doing is we are now editing the data in this toolpath. So for example, we see the diameter is 0.25. That's the data it pulled from the database. We can change just this to 0.29 and calculate that, and then calculate the toolpath and preview the toolpath. And we're going to look at the vector, and you're going to see that the cut is right on the line. But in reality, physically, the router bit was smaller, and so it's going to leave some material right here. So now let's do something a little bit to see what happens when we have changed that data. I am going to come in and create another rectangle, and we'll just plug it in right here. Close that, and we're going to go back to the Toolpaths, and now we're going to do a second pocketing toolpath on this vector. And by default, the software has kept the beast router bit populated in the profile toolpath or pocket toolpath, and it'll keep it there until we change that. So when we select that bit and go to the edit button, we're going to see that that number has held. It is 0.29. So we want to be careful about this. So we have to remember to come back in and fix that number back if we want that number to be changed back for the roughing tool itself. However, if I delete that bit, we'll remove it. Now let's reselect the beast router bit and populate that. Now we'll select the bit, click edit, and we are going to see that it has the original data in it. So in technique number 3, to offset your roughing bit on your carve, you are telling the software that the router bit is cutting bigger than it actually does. And then when you select the toolpath and actually carve it, because it's thinking it's working with a bigger one, actually working with a smaller one, it's going to leave some material behind. Now, each one of these methods has its pros and cons. So we're going to cover the pros and cons, and then I'm going to tell you my preferred method for doing offsets for my roughing bit. And it's a habit of mine, and when you decide on which technique you want to use, you want to make sure you stick with that particular technique. So we'll get to that one. Let's talk about the pros and cons now. If you're getting some value out of this video and learning some stuff about these different techniques, particularly about the offset of these roughing tools, then maybe take a minute and give me a like and leave me a comment. What are some of the things that you might suggest doing and the pros and cons that you see on this? All right, we're going to talk about the pros and cons that I've whipped up real quick, and I'll be looking for your comments to add on top of that. So the first one, technique number 1, the offset allowance. The big pro on that is the offset function is built right into the software and it's right in the toolpath. All you have to do is plug in a number and the software will automatically offset that toolpath so that your roughing bit leaves a little bit of material left. The con is not that big of a deal, but the con is you just have to remember it's part of the process. I'm using a roughing tool, therefore I need to offset that cut. So you can forget until it becomes a habit. So that it can be a big con if you don't remember this. Technique number 2, the vector offset. This is the one where you draw a line and you copy that line and you offset that line inside or however you offset it by the amount that you want the roughing bit to be offset by. The pro on this is it's very visual. You can look at the design and you can see that line, you can see the gap that it's going to create. Of course, that creates a con as well because that offset is so thin. If you're designing a large project, you can't see that there are 2 lines there. And this also requires you to have a little more knowledge. You need to get yourself more organized by creating layers. So I would have an offset cut layer, and then my finish cut layer, my drill layer. Layers are really important to get to know because they help you keep very organized. And if you don't know how to work with layers in your software and you use Vectric, I've got a video that explains to you how to work with layers. I will link that down below. So, and the con with the vector offset is you have to have more advanced skill, and it has to be a habit. The third one, the changing the router bit data, it's kind of a screwy way to do things. However, the big pro on that is you have that data fixed in your database and you never have to worry about offsetting. When you pick your roughing bit like the beast or the hog or whichever one you get, the software will think you're working with a bigger router bit and it will just design that cut around the project with that in mind. The thing about that is, as far as a con, is when it does the carve, it's not going to take into account that it's actually a smaller CNC bit. So we'll cut right on the line in the visual, but in reality it won't. So what is my preferred method? Well, I really don't like the idea of changing the router bit data. As nice as it sounds, it's not something I want to mess with because I'm messing with real data and the real size of the tool. My favorite method and preferred method is doing the vector offset and creating layers. It's what I've been doing for years, and that's the way I like to keep it. And it's a good habit because I like to keep my designs organized. However, if you're relatively new, you may just want to go with the first method, the one that's already built into the software, which is the offset allowance, where you just type in the number and the software will calculate out the tool path for you. And when it comes to the type of CNC router bit, the roughing end mill, that brought this question to me about Toolpaths offset, which led to this video about teaching you about Toolpaths offset, you might want to seriously consider getting one of these if you don't have it. And here's why. You can see in this piece of oak how aggressively this bit is cutting. Think about how much faster your project would run with a bit like this. At IDC Woodcraft, we carry an entire line of the roughing end mills from 1/8 all the way up to 1/2 inch and from standard lengths to long lengths. Starting with this one right here, the Badger. This is a 1/8 diameter roughing end mill. And you can see how aggressively it can cut in this piece of walnut. 1/2 of it, a 1/2 of an inch deep at 150 inches per minute and a 70% step over. Very aggressive for a little tiny bit. And then there's the one you've been watching already, which is the Beast. That's a 1/4 inch standard length roughing end mill. Then there's its brother, the Hog, which has a longer flute length, 1.5 inches. Then we have the Slayer, which is the 3/8 roughing end mill. So we have the standard Slayer and the deep Slayer, and then up to 1/2 inch where we have the Ripper at the standard length and the deep Ripper, which is a long end mill. If you are a hobby type of CNC machinist where you've got a machine like the alt mill or the long mill or something like that, then you generally want to go with the Beast or the Hog or even the Badger, or just get them all in a set. They're all available at IDC Woodcraft, and I will link them down below in the description of this video, or you can go to idcwoodcraft.com and go right to the roughing category and you'll see everything we have in roughing end mills. If you've got any comments you'd like to share about what I've shared or other input, or even questions about CNC, this is a great place to put them in the comments, because I read the comments and you can see by virtue of a video like this, I will respond to those comments when I can in a video for you. I'll be looking forward to your comments. With that, I'm Garrett with IDC Woodcraft, your CNC router bit supply company. You have yourself a great CNC day, and I will see you in the next video. idcwoodcraft.com